Let's dive right into this explainer showcasing a truly remarkable project for the Kaggle AI Agents Intensive. We're looking at VendorBot, the Supply Chain Negotiator. This is an autonomous AI agent built with Google ADK 2.0, and it's designed to completely revolutionize how we handle supply chain disruptions. The disruption problem when supply chains break. Okay, picture this. You're a manufacturer, and you get a critical disruption alert hitting your inbox at 6 a.m. A key supplier is delayed, and suddenly your entire production line is at risk.
Now, usually, resolving a single disruption like this is absolute agony. We're talking 5 to 8 people spending 3 to 7 days just trying to put out the fire. But the project we're looking at today, VendorBot, collapses that entire timeline into under 2 minutes of compute time.
Think about the painful manual chain a procurement team normally grinds through. First, an inventory check, then pulling the legal contract to calculate penalties, getting a lawyer to actually sign off on it, searching the open market for alternatives, routing for budget approvals, drafting a negotiation email, waiting days for a reply, and finally, getting a director to sign a new PO. It's slow, it's expensive, and honestly, it's incredibly error-prone.
So that brings us to the core question we're investigating today. What if an AI agent could own this entire chain? What if it didn't just give you advice, but actually owned and executed the whole workflow?
10-node autonomous architecture, designing VendorBot. Let's look under the hood at how this is built. VendorBot is engineered as a 10-node autonomous graph workflow using Google ADK 2.0.
The core design philosophy here is brilliant. You have 7 deterministic Python nodes running alongside 3 AI LLM agent nodes. It really comes down to this. Pure Python handles the deterministic rules where rules matter, while flexible AI handles the judgment where judgment matters. Here is the exact sequence. We start with the disruption detector, move to the security screen, the legal SLA agent, and a legal approval gate. Then it's on to the sourcing agent, the procurement agent, the negotiation agent, a wait gate, the contract signing gate, and finally PO execution. The agent orchestrates this whole thing, but humans still sign off on 3 totally irreversible decisions: legal penalties, budget overrides, and that final purchase order. VendorBot Live Demo. Seeing it in action. All right, let's actually see this run. We're opening up the VendorBot React dashboard right now to trigger the pipeline. We'll simulate a 5-day delay on SKU 404X, and we're using Gemini 2.5 Flash. Hitting trigger pipeline now. Security and architecture stack, enterprise safety. Okay, stepping away from the demo, let's talk architecture. In a financial and procurement context, you simply cannot play fast and loose with your data. The ethos of this project is captured perfectly by this idea. Security is layer 0, not an afterthought. Think about it. An attacker injecting into a system like this could force a $0 penalty claim, approve fraudulent purchase orders, or leak your internal pricing targets to competitors. It has to be airtight. To make sure it is, VendorBot stacks 5 robust layers of defense. A security screen runs before any LLM ever sees the data, stripping out PII. We have a prompt injection gate. Indirect injection from vendor emails is strictly sanitized. Contract data is salted with opaque placeholders. And crucially, deterministic Python enforces the business rules. That 10% budget check? Pure Python. Literally no prompt injection in the world can trick this agent into approving a 50% price premium. On top of that, we have secure data flow at every single step. The custom MCP server exposes tools using least privilege access.
Pydantic validation guarantees no malformed data ever flows downstream, and the whole system is rigorously mapped against a strict stride threat model.